me an application that isn't demanding high-speed connectivity these days. Don't worry, I'll wait. All right, there may be some applications out there that aren't requiring next-generation connectivity speeds. But for the most part, we're in the middle of a big-time connectivity speed ramp-up. With 5G networks, autonomous cars, high-performance computing, and AI leading the charge, we won't be seeing a slowdown with speeds anytime soon. But how can we keep up with these increasingly high-speed connectivity needs? Our interconnects. That's how. Hi, I'm Amelia Dalton, host of Chalk Talk. As the demand for higher and higher speed connectivity increases, we need to look at our interconnect solutions to help solve the design requirements inherent with these types of designs. In this episode of Chalk Talk, Matthew Burns from Samtec joins me to discuss how Samtec's Flyover technology is helping solve our high-speed connectivity needs. We take a closer look at how Samtec's Flyover technology helps solve the issue of PCB reach, the details of Samtec's Flyover QSFP system, and how this cost-effective, high-performance, and heat-efficient solution can help you with the challenges of your 56 gigabits per second bandwidth and beyond design. And before we get started, don't forget to click that link. There you can find even more information about this topic from Samtec. Hi, Matt. Thank you so much for joining me.
Hey, Amelia. It's great to be with you again.
Excellent. Okay, so we're talking about Samtec's Twinax Flyover systems for next generation speeds today. But Matt, before we get started, what trends are you seeing driving the need for these kinds of speeds?
I think you hit the nail on the head right there, Amelia. There's never a slowdown in speeds that are required in the high-tech industry. Typically, we think of more data, more throughput based purely on data center. At Samtec, we're really seeing three trends that are really driving what we're calling the technical renaissance. 5G, we just noted that early in Q1 of 22, 5G systems are officially being flipped on here in the US. We see a exponential growth in artificial learning, high-performance computing, not only in data centers, but in the edge and the fog. And then we're seeing a ton of autonomous vehicles, right? So we're calling that Auto 2.0. Not only is it the electric car, the autonomous vehicle that you and I may drive, but it's delivery trucks, it's trains. There's increased research going into autonomous planes as well. These catalysts are really growing the demand for data across the electrics industry. It's just not data center, but it's these other catalysts, these other trends that we continue to see. What's interesting too, if you look at the graph on the right-hand side, this is a brief overview of Samtec's view of technical history. Going back to the dawn of the semiconductor revolution, late 60s, early 70s, semiconductors always sort of led interconnect in terms of performance. You see that on the dotted blue line on this chart. And you think about some of the catalysts in the past, personal computer revolution of the late 70s and early 80s, the internet revolution of the mid 90s. Those were really mile markers for increase in performance. But we've sort of seen a crossover in the last 5 to 7 years or so, at least from Samtec's perspective, in that because of the demand for speed due to 5G, AI/HPC, Automotive 2.0, the interconnect industry is really leading performance. So when you look at current design nodes at 56G PAM4, you look at 112G PAM4, which designs are being worked on, and then research is going into 224, there's no end in sight for the demand for speed, not only at the channel level, but also at the port level and at the system level. So we're real excited about that, and it's driving a ton of innovation at Samtec, which we'll talk about today, and we'll look at some of the applications, but also some of the solutions that Samtec offers.
Excellent. Now, Matt, we're not just talking about a couple applications, right? We're talking about a wide range of designs.
That's a great point, Amelia. You know, in the previous slide, we talked about catalysts, right? These are just overall trends. You know, there's a term that used to be used called megatrends. It's probably a little dated from its use, but it encapsulates the idea. 5G networks, AI/HPC, and automotive are not just a single application. They're across many solutions or many applications. You know, when you look at this slide, just kind of walking around it from the upper left, in a clockwise motion, satellites, gene sequencing, AI and vision applications, phased array radar, and other high-speed, high-performance communication from the mil-aero arena, high-performance gaming, right? When I was a kid, I remember using Atari 2600. Pong was like the best thing ever. Now you've got rows and rows of GPUs that are really driving next-generation gaming performances, especially for the metaverse, which seems to be taking over the world here in the near future. For autonomous vehicles, for automotive 2.0 applications, electrification is a trend. Not only do you need to have the power and the storage delivery, but how do you have all the data that monitors that? That's also enabling remote applications when it comes to high performance in autonomous vehicles. Instrumentation and test and measurement needs to keep up with high-speed performance from a test capabilities. Next-gen healthcare, automation, the factory, and process automation. 3D printing is revolutionizing manufacturing, drone technology, and then server-grade performance at the edge of the computing network. So all of these applications and then some are driving the performance led by the catalysts that we talked about, 5G, AI/HPC, and automotive 2.0.
That makes sense. Now, Matt, circling back to what you said about silicon to silicon connectivity solutions, can we expand on that a bit? What does Samtec offer that is included here?
It's very easy to say that Samtec offers any type of interconnect solution from point A to point B, going from one piece of silicon to another. But what does that really mean? We really try to focus on innovative products enabling next-gen system performance, backing that up through what we call full channel system optimization. At a high level, there's various solution blocks that we offer, including high-speed, high-density backplane, extreme density arrays or board-to-board connectors, high-performance test and precision RF, performance optics, high-speed edge card, and mezzanine solutions. And what we're going to talk about today is our flyover technology.
Fantastic. Now, speaking of that flyover technology, what issue is this technology in particular looking to solve?
Well, that's leading us to pop the hood on some of the design challenges that engineers, designers, system architects are looking at. Really, it boils down to physics, right? The faster the data rates are, the shorter the trace lengths that you can send over PCBs. So we have bandwidth requirements increasing, as we talked about, because there's so much silicon that's on these lines. There's heat concerns, routing signals. There's any number of lossy components on a PCB, including vias, potential traces, coupling, components. And that's not simple. It used to be you could put a 100 megahertz signal on an FR408 board and be done with it. But when you're trying to design for 100 gigabit per second, 200 gigabit per second solutions, you really have to pay attention to each particular design component from point A to point B. The graph here on the right illustrates the point. These are some of the very popular transmission mediums that signals go through, getting from silicon to silicon. FR408, when you get above 10 gigabits per second, you're starting to test the limits of the performance of the solution as a trace by itself. Obviously, you can put CDRs and repeaters in there, but that's expensive. There's a lot of heat in there. A design technique to overcome FR408 is to use a low decay dielectric material like a Megtron 6 or a Megtron 7, and that enables you to extend length of traces to a certain degree. But again, as data rates increase, you still run into just the limitations of the transmission medium from a dielectric standpoint. So Samtec's thought process with our flyover technology is let's take the signal out of the PCB and let's put it into an ultra-low skew micro Twinax cable. You can see from the graph here that at 56 gigabits per second, instead of just being a few inches on a Megtron 6, we're getting up to 12 inches of trace length or more.
Excellent. Now, Matt, can we take a closer look at how these flyover systems solve these issues?
Yeah, a good way to do that is to kind of dig a second layer into some of the data on this slide. This shows insertion loss versus frequency of two transmission mediums. The orange line, which is very flat over the frequency range beyond 50 gigahertz, represents a Samtec's ultra-low skew Twinax cable. You can see that there's roughly a few dBs of loss out to beyond 50 gigahertz. The black line corresponds to a traditional backplane PCB trace over Megtron 6. You can see that as the frequency increases, that the loss continues to increase linearly. This growing performance delta as frequency increases gives design assurance not only to Samtec but also our customers and partners that Samtec Flyover technology is a viable, improved performance alternative to traditional PCB substrates.
Okay, so Matt, let's take a closer look at this flyover technology if you don't mind.
Yeah, we'd be glad to, Amelia. So, we talked about the performance of the ultra-low skew cable, and that's really the result of a lot of R&D that we've put into how we actually manufacture these co-extruded ultra-low skew Twinax cable assemblies. Just a few features of the Twinax cable that we offer, the heart of Samtec's Flyover technology. They're ideal for 28 to 112 gigabit per second applications. We're working on R&D for next-gen 224 gigabit solutions as well. The manufacturing of the cable supports tight coupling between the signal conductors, and it also offers ultra-low skew of around 3.5 picoseconds per meter. How are we able to achieve that? Well, if you look at the illustration on the lower left-hand side, you'll see that we do not have a ground wire. The manufacturing of the cable via the co-extrusion allows for the ground wrap and the co-extrusion of the conductors to give tight coupling that the rest of the industry is working to achieve. So by eliminating that ground wire, that third wire, we're able to get performance versus a lot of similar solutions on the market. Advantages of our flyover technology, we've talked about the performance, simplified PCB layout, fewer PCB layers, less expensive PCB materials. We're able to eliminate expensive retimers and CDRs. You can also see, looking at the illustration on the bottom right, that flyover technology allows an ASIC to be moved from the front of the chassis towards the back where the thermal management solutions are. And instead of having that thermal source be in the middle of the PCB, you can move it back towards the fans, and that allows for improved thermal performance.
So, Matt, flyover technology gets data to the front panel faster, right? What solutions does Samtec offer for those applications?
Most of the applications that we've won with flyover technology are exactly what you said, going from the ASIC to the front panel of the design. One of the solutions that's been very popular within the industry is what we call FQSFP, or our Flyover QSFP system. QSFP is the standard MSA pluggable front panel connector. So the cage and the heatsink of our solution complies with the MSA standard. However, the advantage that we bring is that instead of routing traces from the card edge connector through the PCB and then out through the rest of the system in a traditional sense, as the signals come in through the pluggable transceiver, they attach to the edge card, and then we use Samtec's Direct Connect technology to attach our ultra-low skew cables directly to the contact of the card edge connector and the pluggable cage. So that provides a lot of increased performance, thermal mitigation. We've also designed, as you can see in the illustration on the lower center of the slide here, we've also designed the connector to allow for press fit, where the low speed control and power contacts go into the PCB and negate the need for a secondary cable. We also offer system flexibility in terms of the N2 options. If you're an OEM using QSFP infrastructure, flyover technology needs to conform to that. However, the type of connector that's used next to the ASIC within an end market is really up to whatever is best for a specific customer application, whether that's high density, high speed, or something that's lower cost. In addition to what we call our Flyover QSFP, we also have our Flyover QSFP double density. QSFP DD as an MSA builds upon the success of QSFP. It doubles the channel rates, doubles the performance. So we're able to mimic that using our flyover technology as well. Some of the other advantages that our Flyover QSFP DD solution offers: belly-to-belly mating for improved density over the Flyover QSFP solution. It does offer backwards compatibility with QSFP modules. There's a number of heatsink options that are available to help mitigate any thermal concerns, and there are a number of N2 options as well, providing flexibility for this type of solution within a front panel application. We're not stopping with QSFP DD. Samtec is working on a Flyover QSFP DD 800 form factor to support both single and multiple gang ports, belly-to-belly and mezzanine stack configurations as well.
Now, it seems like Samtec offers flyover technology in small form factor pluggable transceivers, right? What if I need high density?
So that's where Samtec's Nova Ray IO panel cable assemblies come in. Nova Ray IO leverages the contact design of our flagship performance board-to-board connector, NovaRay. So by leveraging that contact system, we're able to pack more pairs into a smaller front panel space when compared to QSFP, QSFP-DD, or QSFP DD800. That allows for higher aggregate throughput through the front panel. We have 8 pair, 16 pair, and 32 pair options of NovaRay IO, and we've designed this platform to be flexible to support a number of protocols. A good example of that is the newly released PCI Express 6.0, which supports a by 4 or a by 8 configuration. By 16 also is available. And then as Ethernet and other high-speed protocols continue to increase in throughput, NovaRay IO is flexible enough to support any number of configurations there as well. Another benefit that we have with Rugged IO is rugged external shielding for EMI protection, which again helps to increase the performance of the system at an overall level.
So NovaRay IO is very dense on the front panel. Matt, are there other NovaRay options for midboard line card applications?
The short answer there is yes, Amelia. We talked earlier about how Samtec's NovaRay board-to-board interconnect is our flagship performing connector. We've branched out not only to have the board-to-board solutions, but we also have cable-to-board solutions that use the same NovaRay contact system. So our extreme high-speed, high-density NovaRay cable assemblies are really designed for midboard applications where the ultimate performance is needed to get that data from an ASIC into the cable as quickly as possible. Some of the key features of the design that enable us to do that: the contacts use 2 reliable points of contact, which improve signal integrity, improve the mating. And then we use industry standard BGA attached, not only for density and optimized trace breakout for designing the signals once the connector attaches to the PCB, but there's also manufacturing benefits using standard reflow assemblies for surface mount technology as well.
So, Matt, what if my design requires a very slim cable assembly? What would you suggest in this case?
That's a great question, Amelia, because not every design requires hundreds and hundreds of transceivers routing from the ASIC to the front panel or from the ASIC to the backplane. And in some cases, density, small form factor with high performance is also needed. So one of the key solutions that Samtec offers here is our Accelerate family of slim cable assemblies, really targeted at midboard applications. We have a number of flavors here that offer not only density, but also performance. So our Accelerate cable assemblies, our ARC6 and our ARF6 illustrated on the right-hand side, come in a small 7.6 millimeter body width in a high-density 2-row solution. For Accelerate cable, we offer both vertical mount and right angle mount from the PCB. We support 8, 16, and 24 differential pair configurations, and we have a number of solutions that are also on the roadmap. Accelerate HP is a high-performance version of Accelerate HD. We're developing cable solutions for that. We also have high data rate, high pin count cable systems based on Accelerate HP, and we also have Accelerate HP and a right angle solution with additional features. So whether the design concern is extreme performance or extreme density, Samtec has solutions to fit midboard applications leveraging our FLYOVER technology.
Excellent. Now, Matt, for the highest system performance, signal traces can be as short as possible, right? Does FLYOVER technology attach to IC packages?
Not yet. We're working on that, but we and the rest of the interconnect industry, packaging industry, are evolving towards that. However, Samtec has developed our SciFly ASIC-ADJACENT technology, which is the smallest form factor solution we have at getting FLYOVER technology as close to the chip as possible. SciFly uses an ultra-low profile interconnect system, which is adjacent to the ASIC. It provides up to 16 pairs in an incredibly low 3.8 millimeter profile. The SciFly form factor that's used here also enables the SciFly package to sit right next to an ASIC, and it's short enough to be able to sit underneath a heatsink as well. So that was a major design ask from several customers that we've worked on with this technology, and we're excited to bring this to fruition. SciFly currently supports 112 gigabit per second PAM4 per lane, with a roadmap to 224 when that becomes a viable technology. We also continue to invest in SciFly in development. We have a rugged latching scheme, which will provide some ruggedness to SciFly in cases that are needed. And as you mentioned in your question, we are working on co-package interconnect for next generation systems. Another advantage of SciFly is that it enables extreme channel performance in terms of total throughput through a particular application. Current generations of switching chips from the Ethernet IC providers enable roughly 25.6 terabytes per second in a single 1U chassis. With the next generation of solutions doubling the channel count, that's going to increase to 51.2 terabytes, and that will continue to grow exponentially. SciFly can support both the 25.6 and the 51.2 form factors, and will continue to innovate for next generation solutions as we get later and later in the decade as well.
Excellent. Well, Matt, I think that's almost all I have time for today. But before we go, can you recap your main points for me?
Yes, Amelia, we'll be glad to. A couple of the key points we hope your listeners take away is that first and foremost, Samtec Flyover technology breaks the constraints of traditional signaling. Instead of routing signals through lossy PCBs, we get that signal out of the PCB and into ultra-low skew Twinax cable as quickly as possible. The results of this are a cost-effective, high-performance, and heat-efficient answer to the challenges of 56G, 112G, and 224G designs and beyond. We also back that up with an industry-leading global team of technical experts, online design tools, world-class customer service, and all that's available for any support application. We've also recently released an updated FLYOVER technology brochure, which is available on the Samtec website. For more information on all FLYOVER technology, please visit samtec.com/flyover.
Excellent. Well, I think that is all I have time for now. Thank you so much for joining me yet again, Matt.
Amelia, it's always a privilege, and we love talking with you and your listeners.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Samtec. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or check out YouTube, youtube.com/EE Journal.